So this first section of 3-4 is review. Complete review from before. So if I were looking at letter A, what am I going to do there?
32 to the 2.
Very good. This becomes 2 to the 5th. Very good. So x is going to go to 5. All right. How about this one? It's natural log of x minus, see, and it's going to look very much like the one on the board here. Natural log of x minus natural log of 3 is going to equal 0. How else could I rewrite it? Close. If you're going to combine them, you just write your natural log one time. So that one can go to natural log of x over 3. And it equals 0. So here's what we're trying to figure out. All right. So, right, we want to know what x is. So, I don't think it would be 0.
If you just went back to the original one, you can lump 3. And basically, if they're the same thing, you can subtract from the other.
Right. Very good. So we could go this route because this would be saying e to the 0 power equals x over 3. And what is e to the 0 power? 1. And so then we can get to where x, so this is 1 equals x over 3, so x has to equal 3. So you can go that route, or we can do exactly what Connor said. Go back up here, and we could think of it as natural log of x equals natural log of 3, and now by 1 to 1, x equals 3. In actuality, this is kind of why I like logarithm problems, because there's more than one way to get an answer. And all of the ways, as long as we do them correctly, should yield the same answer. Excuse me. So I'm going to pause. Dana and Timmy, you guys are getting paused for a moment, and we'll put the answer up off on them. So we flew through the first part here. We inverted the 3, and then we ran from there. I'm going to let you get it. But when we come over to this one, do you know the answer? The silence is a good indicator. I don't know the answer either. So we've kind of run out of options in what to do in exponential form. So how can I rewrite that if I don't know what to do in that form? Very good. Log base e, which instead of writing log base e, we usually write, very good, this would be natural log of 7. Very good. And then that would be a matter, you can go either way, but this now is just a matter of grab your calculators, type in natural log of 7, and get your answer, or we can even just stay right there. We can go decimal, or we can just say x is going to be natural log of 7. So we're going to be content right there at that point. All right. Excuse me. Sorry, Timmy. Dana. I have a frog in my throat, and I hate that. So this one, I've run out of things I can do here. I don't know what to do in logarithmic form. So now I want to backtrack, and I want to go to exponential. So Connor, what's the green one in exponential form? Very good. E to the negative 3 equals x. Then you can use your calculator if you want to and go decimal to get your answer. Works great. This one, I don't know what to do in that format. So Karina, what's my base in regular log with nothing shown down there? 10. So this would be 10 to the negative 1 equals x, or 1/10 is equal to x. So Connor, when you asked about the assignment, that's why the assignment's as long as it is, because some of them are just fly through them, and I write them like that. Now we're going to move to something slightly different. However, I don't think this is going to frighten you too much. This is very much the one-to-one property. If I have e to the negative x squared equals e to the negative 3x minus 4, what can I do? Very good. It is quadratic. I can pull, because it's the same base, I can just pull the exponents out and work with them. So opposite of x squared minus 3x minus 4. And what Lily said was it's quadratic. So I can move my x squared over, and I would have 0 equals x squared minus 3x minus 4. Does that factor? What's it factor to? X minus 4 plus 1 equals 0. So I would end up with 4 and negative 1 as my solutions. And I think that would be okay. In this particular format, we'll get the same answer either way. So yeah, I'm checking it. Sorry, that was my hesitation. I was looking to make sure they both worked, and they do. I always double check to make sure they both work. Questions, are you okay? We're good? How about that one? What am I going to do to try to solve that one? If you just were handed it, and I didn't give you any instructions, I just said try this. What's one thing you think you could do first? Right, and instead of factor out the 3, just divide it off. There's no reason we even need that there. So we can divide the 3 off, and we're left with 2 to the x power equals 14. Is that correct? Did I really divide that right? Okay. I don't really like that one quite as much, because 2 to no power is going to give me 14. I do know that. So now I've kind of run out of ways to finish this exponentially. I could break it down some, but it's not going to help. So at that point, since I've reached the end of my rope this direction, I'm now going to switch it over to logarithmic form. And so I have log base 2 of 14 is going to equal x. And if I had to get my answer there, I could definitely do a change of base. So I could type in log of 14 divided by log of 2 will equal x. I feel like there's another way we could have done that one, but this is the method that's coming to my mind right now. And if I type in log of 14 divided by log of 2, I will get, okay, after waking up everybody in the room, we got 3.807, making sure people are alive. So this one now, we have e to the x plus 5 equals 60. So looking for some way to simplify this in any way so that we can work with it a little more. Karina, what would you do first? By adding, subtracting, multiplying, dividing? Subtracting. So e to the x is going to equal 55. And now, I don't know that answer. So Lily, what could I switch it to? Perfect. Natural log of 55 equals x. And at that point, I'm going to trust you guys to be able to type natural log of 55 in on your calculators. I think that portion you would be okay with. And Lily is doing it. What did you get? 4.007 is what she said she's got there. So now we have 2 times 3 to the 2t minus 5, and then minus 4 equals 11. 2 times 3 to the 2t minus 5 minus 4 equals 11. This one's more complicated. But if you think of it as a normal equation, one that you've been doing since Algebra 1, Connor, step 1. Move over the 4. So we're going to have 2 times 3 to the 2t minus 5 equals 15. Ooh, I don't like this very much. Then what do I have to do? Yeah, and there's where I didn't like it. Because now I have 3 to the 2t minus 5 has to equal 15 over 2. Well, 15 over 2 is 7.5 if I want to think of it that way. But I definitely have no idea what I would have for t. No clue whatsoever. So I need to switch formats. We're going to go logarithmic form on here. So I'm going to have log base 3 of, I'm going to go 7.5. Log base 3 of 7.5. 7.5 is the same thing as 15 over 2. I just didn't want to write 15 over 2. Equals 2t minus 5. Equals the exponent. Now at that point, I would do a change of base. And again, I feel like there's another way that I usually do this all other years. But today, this is the method that is coming to me. So log of 7.5 over log of 3 is going to equal 2t minus 5. And log of 7.5 divided by log of 3, Connor, I saw you typing. What'd you get? 834?
Yeah.
834 equals 2t minus 5. Now keep in mind we did round right there. So whatever we get as an answer is going to be an approximation. But I can move my 5 over and I'll have 6.834 equals 2t. Divide off my 2. And now I could say, all right, 3.417 approximately is what t could equal to get me to that point.
It's the same thing if you do approximate. I mean, not approximate, the opposite of approximate.
Equals?
If you don't round,